The next topic is characterizing schedules based on recoverability. The schedules can be classified into two main classes. One is recoverable schedule and second one is non-recoverable schedule. So the recoverable schedule is a one where no committed transactions need to be rolled back. That is, we can call it as a recoverable schedule where, so for example, if a transaction t1 t2 3t, so some transactions will be doing some read and write operations. So if they have not committed, in between the transaction failure occurred, then so we can recoverable that kind of schedules, which is the one where no committed transactions needs to be rolled back. That is recoverable schedule. For example, so in general form or else in the format, we can explain a schedule S is recoverable if no transaction T in S commits. So if it is committed, then it can't be a recoverable. So if no transaction T in S commits until all transaction T that have written an item that T reads have committed. So therefore, this kind of schedule we can call it as a recoverable schedule. Non-recoverable schedule. The non-recoverable schedule is nothing but a schedule where a committed transaction may have to be rolled back during recovery. So that is we can call it as non-recoverable schedule. But this a non-recoverable schedule, whenever a committed transaction you want to be rolled back, in that case this will going to violate the durability from the asset property what we have learnt. So therefore a committed transaction cannot be rolled back. So non-recoverable schedules should not be allowed for these kind of committed transactions. So that is about the uh, classified or the schedules can be classified into two main classes, that is recoverable schedule and non-recoverable schedule. So it might be clear that recoverable is nothing but if the transactions are not committed, then we can roll it back and then we can recover those uh, schedules. But in case of non-recoverable, when the transactions are committed, if you want to roll it back, then asset property will start to violate, especially durability. So therefore non-recoverable schedules should not be allowed to do the roll it back or else roll back or recoverable schedules. So that is what we are calling as a non-recoverable schedule and recoverable schedule difference. Now, so in this slide, we will see an example for the recoverable schedule and non-recoverable schedule. So for example, schedule A below is a non-recoverable. Why? Because T2 reads the value of X that was written by T1, but then T2 commits before T1 commits or aborts. So therefore, these kind of transactions we can call it as a non-recoverable schedule. So to make it recoverable, the commit of T2 of C2, that is from the transaction 2, must be delayed until T1 either it will going to commits or else so it will going to abort the transaction. So then we can make it as a recoverable. That is the example for non-recoverable and recoverable. If T1 commits, T2 can commit. If T1 aborts, T2 must also abort because it read a say value that was written by T1. This value must be undone when T1 is aborted. You can see. So this is known as, we can call it as cascading rollback. So schedule A is there, schedule B is there. You can see from the schedule A, below is one of the example for non-recoverable, because T2 will going to read the value of x that was not committed or not written by the T1. So but then T2 commits before, so we were committing the or aborting the C1. So therefore this kind of transaction we can call it as non-recoverable. When we will see a schedule B, you can see, to make it as a recoverable, so what we are doing means, so we will going to commit the transaction 2, that is C2, must be delayed until the either transaction T1 will going to commit or else it will going to abort. So therefore in the schedule B you can see C1 will going to commit first or else it will going to abort, then only, so it needs to be followed by the T2, either it will going to commit or else it will going to abort based on the transaction T1. So therefore if T1 will commits, then T2 will commits in the schedule B. If T1 will going to abort, then T2 will also going to abort their transactions. Therefore this kind of transactions are the example for the non-recoverable and as well as recoverable schedules, so which we have learnt from the previous slide. So this kind of process we can also known as cascading rollback. When T1 will go into abort, T2 must abort. So then if the T1 will be written, so then the T2 must be undone when T1 is aborted. Therefore, so that is what we can reset to old value. So if it is aborted by T1, so with respect to the T2 transactions. So here, so we can also further refine a recoverable schedule. How we are going to refine or redefining or this recoverable schedule means based on the cascadeless schedule. So cascadeless schedule is nothing but a schedule in which a transaction T2 cannot read an item X until the transaction T1 that last wrote X has committed. Okay, so means, so here in a schedule, so transaction T2 cannot will not going to read an item X until and unless the transaction T1 will write X has committed. Okay, once it written, then only the T2 transaction will going to read that kind of item. This is what we can call it as cascadeless schedule. So the set of cascadeless schedule is a subset of the set of recoverable schedules. The schedules requiring cascaded rollback. Yes, always. Why? Because so schedules are there, so it requires a cascaded rollback also. For example, you can see a schedule in which an uncommitted transactions T2 that reads an item that was written by a failed transaction T1 must be rolled back. That is, so uncommitted transactions are there. If uncommitted transactions that is, let us consider there is a T2 is there. T2, if it is an uncommitted transaction, then so which want to read item which has failed transaction of the T1, then so T1 must roll back. So then T2 should not read that kind of items. So but these kind of schedules is are requiring, that is cascading rollback. Whenever uncommitted transactions are there, if another transaction will going to read or write some items, so from that transaction, then so it is required to roll back those kind of transactions. So that is what we are calling it as a schedules requiring a cascadeless rollback. So now we will see the example of cascadeless and as well as so not a cascadeless examples of transactions. For example, there is a schedule B. You can see here there is a schedule B is there. So this schedule B below is not a cascadeless, because now you can see here the transaction R2 is there. It will going to read the value of X which has been written by uh, R1, that is nothing but a T1 transaction. So before commit, which will going to read the value, So this is what we are calling it as a not a cascadeless transaction. Okay, this is a example for the not a cascadeless transaction. If for example here what happens, if a T1 will aborts or it is failured, then T2 must also abort. That is nothing but it needs to roll back based on the T1 transaction, that resulting in cascading rollback. The word we can call it as cascading rollback. Based on T1 transaction, T2 transaction will be depends. If the T1 transaction will get failure, then T2 will also failure, and then it will going to roll back all the resulting. That is nothing but that process we are calling it as a cascading rollback. So to make it a cascadeless, so then we will move to the how we are going to make it as a cascadeless transaction. R2 of X of T2 transaction must be delayed until T1 will get commits. Okay, so you can see here the schedule C is that R1 will going to read the item X and then it will going to write the item X. So after that, once again it will going to read the Y value and it will going to write the Y value. Whatever the transactions are there, that will be performed, and then it will be going to commit. That is nothing but T1 transaction will going to commit. After that only the T2 will be performing operations of the read operation or write operation. So this kind of transaction, so we can call it as a cascadeless transaction. So means full after completion of the write operation of the one transaction, then read needs to be performed by the another transaction. So this kind of transaction we can call it as a cascadeless transaction. In case, so not a cascadeless transaction, what happens when a T1 transaction will be writing some item, so that might be a write of X. In that case, if the T2 will go, if T2 will perform a read operation of the same value, if transaction T1 is not at all committed, so but T2 is started to performing some operation like read or write operation, but T1 is not committed is a transaction, then if T1 will get failure, then automatically T2 will also get failures. Therefore, that kind of transaction we can call it as a cascading rollback. So next is cascadeless schedule, which can further we were going to refining. So like strict schedule and blind write. The strict schedule is nothing but a schedule in which a transaction T2 can neither read or write an item X until the transaction T1 that last wrote X has committed. That is, whenever a T1 wants to perform some transaction, either a read operation or a write operation, which will perform if and only if the T1, so which is write an X item which has been committed. After writing operation has been done by the transaction T1 and it has committed its transaction, then only the T2 will perform either read operation or write operation. That kind of schedule we can call it as a strict schedule. The set of strict schedule is a subset of the set of cascadeless schedules. If blind writes are not allowed, all cascadeless schedules are also strict schedules. Okay, what is meant by a blind write? The blind write operation, that is W2 of X, that is not preceded by a read of R2 of X. So for example, without reading, if you are writing the object into the database, you are updating the data, then we will call it as a blind write. Without preceded by a read operation, if we are performing a write operation, then we will call it as a blind write. That is the major difference between cascadeless schedule, which is further refined, and as well as so which we have gone through with the last one. So that is strict schedule and as well as blind write schedule. Now we will see one example for the cascadeless or also strict schedule. Schedule C, which is given below, so is a cascadeless and also it is a strict schedule because it has no blind write. You can see if it is as a blind write, then we cannot call it as a strict schedule. Okay, we can call it as simply a cascadeless schedule. Schedule D is a cascadeless but not strict because of the blind write w3 of x, which writes the value of x before t1 will get commits. Okay, so therefore to make it a strict, w3 of x must be delayed until t1 will get commits. See the schedule E. So you can see here the schedule C they have given here. R1 of x means transaction T1 will be performing the read operation, then it will be performing the write operation of x, then reading of the item y, that is transaction T1 will be performing, and once again it will be performing the write operation of the y object, and then it will be committing with the C1 transaction. So then R2 will be starts to read the object of x, then transaction T2 will also perform the write operation of x. Therefore this kind of schedule we can call it as cascadeless, and also we can call it as a strict schedule. So why? Because after committing of the transaction T1, then T2 will be performing the read and write operations. But when I'll move to the schedule D, that is, so it is a cascadeless. You can see here R1 of x will going to read the value, W1 will going to write the transaction T1 value, but W3 of x is there, so which is a blind write of x. Why? Because we have not at all, transaction T3 is not at all read that x before reading that x value. So we are writing the our transaction T3 is performing the write operation. Therefore which will going to write without committing the transaction T1, so that the transaction T3 is writing the x objects, then so we will call it as a, so it is not a strict, so this is what just cascadeless, but it's not a strict schedule. So that is an example for that. Schedule D is example for that, not a strict but it is a cascadeless schedule. So you make this one, so to a stricter one, so cascadeless but not strict one, we want to convert it into a stricter one. What we need to do now, we can do it. So strict, if you want to make it as a strict schedule, then w3 of x must be delayed until what? Until t1 will get commits. Okay, so you can see here, so schedule E is there, R1 of x will going to transaction T1 will be performing the read operation, and after that it will be performing the write operation. Transaction T1 same transaction. Now the same transaction T1 will be performing the read operation on Y object, then it will be performing the write operation of Y objects. Some of the transactions are undergoing like by using a transaction T1, that is read and write operations. After that only it will going to commit, that is C1, means transaction T1 is committing whatever the value updated, that of Y value and X value has been updated in the database. Now W3 of X is there, which will going to write performing the write operation for transaction T3 in the database. Okay, so now this can be a strict so schedule. Okay, means cascadeless strict schedule we can call it as. So if and only if, so until and unless T1 will get commits, so if you are writing a object into the database, then we can call it as a blind, so blind write, else so we can convert it into a stricter one. This is the procedure how we can also convert blind write into a so cascadeless strict schedule.